In our last two chemistry videos, we learned a lot about ionic bonds. However, all of the example ionic bonds that we have looked at have been what are called binary ionic compounds, meaning that they are made up of two elements. And since it's an ionic compound, it can always be broken down into one element in the cation bonding with one element in the anion. But ionic bonds are not limited to just this. They can have any number of elements in the cation and any number of elements in the anion. So when there are more than one element in the cation or the anion, it's called a polyatomic ion. So just to be clear, let's write out a concrete description of what a polyatomic ion is. A polyatomic, we can split up the word polyatomic ion into the parts poly, meaning many, atom, which we know it's an atom, and ion. So we can conclude that a polyatomic ion is an ion with many atoms. In this case, atoms means elements. So a polyatomic ion is just an ion that has multiple different elements in it. And it can fill in as a cation or an anion based off of its charge in an ionic bond. So what are some examples of polyatomic ions? Well, there's ammonium. Ammonium's formula is NH4, and its charge is +1. So in an ionic bond, it will be the cation. Another example is sulfate. Sulfate's formula is SO4, and its charge is 2-, so it can be an anion in an ionic bond. Now, there are a lot of polyatomic ions out there. So what I will do is I will put a link to a list of common polyatomic ions in the description below. So let's look at some practice problems with our polyatomic ions that we have gone over. In our first one, we will go from the name to the formula. So the name of our compound is ammonium sulfide. So we can break it down into its two parts. Ammonium is the cation since it comes first, and sulfide is the anion since it came after. Now ammonium, as we see here, has the formula NH4, and it has a charge of +1, and it is bonding with sulfide, which is just sulfur with its ID ending. So it'll be S, and it has 6 valence electrons and a charge of 2- when it completes its shell. Now, this isn't balanced, right? +1 and 2- do not cancel each other out. So what we need to do to balance it out is take 2 ammonium ions. But you can't just put a 2 at the end, because then this is confusing. NH42, no one really knows what that means. So what we do is we put a parenthesis around the ion, so NH4, and then we put our 2 after that. So that tells us that we have 2 of this entire group. And that multiplies our charge by 2, giving us a 2+, which does cancel out with 2-. So you can rewrite ammonium sulfide as NH4 in parentheses, then 2, and then just S. So that's ammonium sulfide. These two are interchangeable. Now let's look at an example where we go from the formula to the name. So our formula is Fe2, open parentheses, SO4, 3. Okay, so since we're going to the name, we shouldn't have to actually calculate any charges. However, iron is our cation, and it is a variable ion. So we're going to need to find out how many valence electrons it's giving up. So we can split it into its two parts, iron, and then this is sulfate, since it's in the parentheses, and that's what sulfate looks like. So it's Fe2 bonding with SO4, SO4, except we have 3 SO4s. And as we can see here, each SO4 molecule has a charge of 2 minus, but since we have 3 of them, we multiply this by 3 to get a charge of 6 minus. Now, and we know that our ionic compounds have to balance out, so the cation has to have a charge of 6 plus. And we have 2 iron atoms in the cation, so 2 times the charge of each individual iron atom is equal to the total charge. And 2 times what is 3? Well, obviously 2 times 3 is 6. Sorry, 2 times what is 6? Obviously 2 times 3 is 6. So we know that each iron atom is giving up 3 valence electrons. And now we have all the information we need to write out the actual name of our compound. So we start with our cation, which is iron, and since it's a variable ion, we need to specify how many valence electrons it's giving up, and that is 3, so I. Then we do our anion, which is sulfate. So we take our sulfate, and normally we would get rid of the ATE and give it an IDE ending, since it is the anion. However, if we made sulfate into an IDE ending, it would be sulfide, which is what sulfur should be when it's an anion. So that would make it confusing, and it would make it impossible to tell what the formula of iron 3 sulfide is. So what you do with polyatomic ions in the anion position is you just leave them and take the direct name. You do not give it an IDE ending. And that's it for our lesson on polyatomic ions.